All right, let's do this. We're about to go on a journey back to the very beginning of everything. In just the next few minutes, we're going to unpack the origin story of our entire universe, from a single, tiny point to the absolutely vast cosmos we see today. You ready?
I mean, it's the ultimate question, right? For as long as we humans have looked up at the stars, we've wondered, where did all of this come from? Well, science's best answer is a theory that started taking shape more than 100 years ago.
But hang on. Before we go any further, we have to clear up the single biggest misconception out there. That name, Big Bang, probably makes you picture some kind of massive explosion happening in space. But that's not what the theory is about at all.
So let's really get to the heart of what the Big Bang Theory actually says. Because it's a concept that's, frankly, way more profound and a whole lot more interesting than just a simple explosion.
See, the theory isn't really about a moment of creation from nothing. It's about how our universe evolved from an incredibly hot, super dense state. And the key word here, the most important word, is expanded. The universe began to expand, and guess what? It's been expanding ever since.
Okay, here's the best way to think about it. Picture a loaf of raisin bread baking in the oven. The dough is space itself, and the raisins are all the galaxies. As that dough bakes and expands, it carries all the raisins along with it. So from the point of view of any one raisin, it looks like all the other raisins are moving away. This is so important. It's the space between galaxies that's stretching. The Big Bang was the expansion of space, not an explosion in it.
The guy who first came up with this incredible idea was Georges Lemaitre. He was a Belgian physicist and also a priest, which is a pretty cool combo. Back in 1931, he basically said, look, if the universe is expanding now, then it must have been smaller in the past, right? All the way back to a single, what he called, primal atom.
So, if the theory is about expansion, where did that misleading name even come from? Well, ironically, it came from someone who hated the theory. An astronomer named Fred Hoyle was on a BBC radio show, and he used the phrase Big Bang to make fun of an idea he thought was just completely absurd. And, well, the name just stuck.
So why do pretty much all scientists accept this theory today? It's because the evidence is, frankly, overwhelming. And it's written all across the night sky. So let's take a look at the smoking guns.
We can really break down the proof into 4 main pillars. Now, any one of these is a huge discovery on its own, but when you put them all together, they build an incredibly strong case for the Big Bang.
First up, we have Edwin Hubble's game-changing observation. He noticed that the light coming from distant galaxies was stretched out to longer, redder wavelengths, something called redshift. This was the first real, direct proof that the universe is actually expanding, just like Lemaitre had predicted.
Second, there's the cosmic microwave background, or CMB. You can think of this as the universe's first baby picture. It's this faint glow of light left over from when the universe was just a toddler, only 380,000 years old. It was actually predicted in the 40s and then discovered completely by accident in 1964. It's a literal snapshot of that hot, dense state our universe grew out of.
And third, the recipe of the early universe. This one is just incredible. The Big Bang Theory predicts the exact amounts of the lightest elements, like hydrogen and helium, that should have been cooked up in the first few minutes. And when we look at the oldest stars out there, we find that the amounts match the predictions perfectly. About 75% hydrogen, 25% helium. It is a stunning, stunning confirmation.
Okay, so with the theory and the evidence laid out, let's trace the epic story of our universe. We're about to fly through 13.8 billion years of cosmic history. Buckle up.
So, in the very first second, the basic forces of nature split apart. By the 3-minute mark, the first atomic nuclei, hydrogen and helium, were forged. Then, at 380,000 years, the universe cooled down just enough for light to travel freely, which released that cosmic microwave background we just talked about. It took about another billion years for gravity to start pulling matter together to form the very first stars and galaxies. Then, something strange happened. Around 9 billion years into the story, a mysterious force started making the expansion speed up. And that brings us all the way to today, 13.8 billion years after it all kicked off. But here's the thing. As much as we've figured out, the Big Bang Theory has also shown us just how much we don't know. The universe is still hiding some really, really big secrets. And that brings us to the biggest mystery of them all. Just look at this. Everything we have ever seen, every star, every planet, you, me, everything on the periodic table, we call that ordinary matter, and it makes up less than 5% of the universe.
That's right. 95% of the entire cosmos is made of something else, something we can't see or touch. We call it dark for a very simple reason. We have almost no idea what it is.
So this leaves us with these just colossal questions. What is this dark matter that seems to be the invisible scaffolding holding galaxies together? What is this dark energy that's pushing space apart faster and faster? And a really deep one, why is there so much more matter than its opposite, antimatter, in the universe? These are the questions on the very edge of physics today.
And that leads us to one last truly mind-bending question to leave you with. If the Big Bang is the expansion of space itself, and the universe is all of space, then what is it expanding into? The honest answer? We don't know. And that right there is the wonderful, humbling, and